Alright, Pre-Calc 12, we're continuing on with trigonometry. And today is a little overcast outside, good times. So here we go. Trig derivatives, 7.2, 7.3. So we'll be doing all the derivatives of sine, cos, tan, cotangent, cosecant, secant. And we're going to develop them from scratch, and then from that point forward you will then have to kind of memorize them for your future in math. So here we roll. What we're going to look at is we're going to show, and I just want to, before we get into this, remember we talked about this in class, but I want to be aware where this came from. The derivative of sine is cos, and I'm just going to show you a quick little Desmos graphic, which I went to Desmos. We did this in class too. So I've graphed sine. So if I click on there, there's the sine graph, as you all know. And then if you were to sketch the derivative of this, here it's positive slope, zero slope, negative slope, and sketch that. We did that in class as well. With Desmos, I'm not sure if you're aware, there is a derivative button. It doesn't actually give you the actual derivative equation, but it gives you the graph, and that is if you go to the toolbar here, functions, and under miscellaneous, it's the ddx, and you click on that, and you just tell it what to take the derivative of, and I'm taking the derivative of f of x, which is sine. And then when I click on it, here we go, there is the derivative, which is cos. If you were doing this as a human, you wouldn't know if that was exactly 1. We're going to prove that it is. All right, so that's the first thing we'll prove. Then we'll look at the other ones real quick. Oops, zoomed in, zoomed out. So let's roll with this. All right, so let's prove that this is actually true, not just with the verification of Desmos. So to prove this, like any new derivative, we need to start with the definition of the derivative, which is f prime of x equals limit as h approaches 0 of f of x plus h minus f of x over h. And then I went, and this is where it's a little bit new, is because now the function is now trig. So I went and plugged x plus h into the sine function, and you end up with this. Now for polynomials and any other types of functions we dealt with so far, this would end up, you'd be able to factor or expand, but unfortunately with sine of an addition, you cannot distribute that. We're going to have to use this sum and difference identity. So we're going to invoke this identity, which is on your identity Pre-Calc 12 sheet, which I need to attach as well to this assignment because it does come in handy, although to be honest, well, you do need it. So here we go. So I'm going to replace this with this, which gives me sine of x times cos of h plus cos of x times sine of h minus the sine x at the end there over h. All right, and what does that bring out? Well, remember from before, the limits that are now going to be really helpful to us, limit as x approaches 0 of sine x over x is 1. Or in this case, limit as h approaches 0 of sine h over h will approach 1. So can we get it? Now there is a sine h over h in here, but it's embedded within the addition subtraction, so I can't just look at that alone. We're going to have to do something a little bit sneaky here. Notice there's a sine x here and a sine x here, so with a little bit of algebra manipulation, I'm just going to write the order of that sum and difference in a different order. Out of this, I'm going to factor out a sine x. Also, while we're on to this, remember also there was a limit we did last other day, which was cos of x minus 1 over x is 0, which we did with the conjugate. So just keep that in our back pocket as well. So these are just fact. It's going to come out to play here. Now, you won't have to prove this. I mean, again, university, your prof might love this. I'm factoring out a sine, and as I factor out a sine, I won't factor out a sine x there because there is none. Leave that alone. If I split this up into two independent pieces, you get sine x times cos of h minus 1 over h plus cos of x times sine of h over h. As I split that into two independent fractions, This fact as h goes to 0 is 1. This fact as h goes to 0, here it's x, but it's h in our case, goes to 0. So 0 times sine of x is 0 plus cos of x. And there we've just proven that the derivative of sine is cos, beyond a shadow of a doubt, as long as you believe this trig identity, as long as you believe this limit fact and this limit fact. We didn't really need this. We could have used the conjugate here, but this was just a quicker way to get to it. So that being said, now what comes out to play is a lot of stuff. So we now know this, what you need to know. The derivative of sine is cos. You can also prove, doing a similar thing, do it for cosine. The derivative of cos is negative sine. And again, with the Desmos application here, let me get rid of that. If I go to graph, there's cosine. If I graph its derivative, that derivative there, that is negative sine, because the slope here is 0, slope there is negative. You can prove that as well. That's a verification of it. So now, these are two facts that we now know. You now know the derivative of sine, you now know the derivative of cosine. Alright, so that being said, we're now going to prove what the derivative of tan is. This wasn't, we didn't prove that, but you could do the same thing. We're going to prove tan, and then using the same kind of technique for tan, you can prove the derivative of cotan, cosecant, and secant. Now you don't have to memorize all of these. You could derive them from scratch like we are now, or you could, I would highly recommend you memorize these, because these will make your life a lot easier. So what we're going to do for tan, instead of using limits, which is kind of, limits are cumbersome and awkward, we're going to write tan using a trig identity. Remember, tan is sine over cos, and if we can write tan as sine over cos, and we know the derivative of sine and cos now, we can now use the quotient rule, because tan now is a quotient. So if I use the quotient rule on this, where remember this is my top function, this is my bottom function. The quotient rule is the bottom function, so cos of x, times the derivative of the top function, so it'll be the derivative of sine, minus the top function times the derivative of cos, all over the bottom squared. So now with these facts, now here's again more facts. That's the beauty of math. We got one fact that builds on another fact, which builds on another fact. So we're going to pull out the derivative of sine. We'll replace this with cos. The derivative of cos we'll replace with negative sine. So you end up with cos of x times cos of x minus sine of x times negative sine of x. And I end up with cos squared, double negative there, plus sine squared over cos squared. Cos squared plus sine squared, or sine squared plus cos squared, screams Pythagorean identity 1. So we're making it look simple. I could memorize the derivative of tan to be this, or 1 over cosine squared is secant squared. So there's the derivative of of tangent. The derivative of tangent is secant squared. All right, and notice these are just, the angles are just x so far. We'll get to that when they're more complicated. In the same light, you can derive cotan. The derivative of cotan, you'll find out, is negative cosecant squared. And then you could also do secant. Secant you could write as 1 over cosine, use the quotient rule again, and the derivative of secant, manipulating it as simple as possible, becomes secant x times tan x. And cosecant is negative cosecant x times cotan x. Now I haven't done these in a while, but I know these forever. Like maybe in 10 years, if I don't do math for 10 years, I'll forget these. But I remember these every year. I might have to look the odd one up because they're not used often, but you need to know those. So that's where I'm going to end this little mini lesson right now. And what I'd like you to do, it's not even in the textbook really, in the sense of I just want you to memorize these. Like go and quiz people. Go for a run, and as you walk by someone 6 feet away from them, you can say, hey, what's the derivative of tan? And then they'll look at you oddly, like they probably are anyway because you're 6 feet apart. And they should know it's secant squared, but you can just yell at them, secant squared, and it'll just create more awkwardness in our already awkward world. So really, no one will really even notice. So that's what I would advise that you do. If I see you walking and then also 6 feet apart, I will yell at you, what's the derivative of secant? You should be able to scream secant x tan x. Okay, so I'm going to stop the video there, and then the next level will be taking derivatives of these with chain rules and product rules and quotient rules. And that's where we'll end this lesson. Thank you.